Okay, so basically when you're using Gaussian elimination, you're only using the coefficients of your equations in the matrix. And so down below the equations that you gave me in green, I have the identity matrix and kind of where we're going to. This one right here just basically means 1x, and my little dotted line here, this is equals and this is a. So at the very end, we're going to have x is equal whatever that value is there, y is going to equal whatever the b value is, and z is going to equal whatever the c value is. So this whole process is kind of like elimination without the variables in the equation. And so I've already taken the time to create the matrix that would represent this system of equations. Now, the order that I'm going to do things in isn't the order you have to do things in, but it's just I'm just going to kind of explain my thought process as I was going through it. So the one thing that I noticed is that if I add this equation plus this equation together, what happens is that I'm going to get 0 when I add these numbers together. So what I can do here is I can take row 2 plus row 3, and then I'm going to replace one of those rows, and I'm going to replace row 3. So in each step here, I'm going to try to just change colors with things that are changing. So the first row is not changing. That's a positive 9. And I'm not going to change the second row here. I'm going to keep the second row the same, but the third row is going to become, now I'm adding all of rows 2 and 3 together. So when I do that, 1 plus 3 is 4. 1 plus negative 1 is 0. 1 plus negative 1 is 0. 9 plus negative 1 is 8. All of a sudden, this row looks a lot like, and I'm trying to get my highlighter to change here. I'm not sure if it's going to change or not. This row is looking a whole lot like this row. Okay, so here's what I'm going to do. I am going to divide that first row by 4 because that'll make that first element in the table a 1. So here's what I'm going to do. I'm going to divide by 4. I'm going to replace row 1. And honestly, all I'm going to do is I'm going to move rows 1 and 2 down to become rows 2 and 3. Okay. So when I divide that first row by, or last row by 4, I get 0, 0, 0. And 8 divided by 4 is 2. That means x is going to be equal to 2. I know that that's what's going to be. Now, those other 2 rows, I'm going to just move down. Okay, I'm not changing anything about them. I'm just bringing them down. I'm just reordering things. Yes, there we go. Now, when you're deciding what to do next, kind of see if there's just an operation that pops out at you. Okay, an operation that pops out at me is this. I know that if I add those 2 rows that I have in red now together, the third column in, I get zeros. Okay, I get zeros. So here's what I'm going to do. I am going to add row 2 plus row 3, and I'm going to, because I'm going to get 0 when I add these together, I'm going to replace row 2. I'm having a little bit of technical difficulties here. I'm going to replace row 2. First row is going to stay the same. The last row is going to stay the same. And I am going to, again, I'm adding together row 2 and 3. So 2 plus 1 is 3. 3 plus 1 is 4. Negative 1 plus 1 is 0. And 9 plus 9 is 18. Now, the nice thing is that this element here, whoops, again, I'm having some technical issues here. This element right here in yellow that I highlighted in yellow, that's what I want it to be when I get to the identity matrix. Okay, so what I really would like to do next is make this element a 0. Okay, so I could use either the first row or the last row, but I want to add this row to something that won't affect that 0 right there. Okay, and so here's what I can do. I can multiply, and I don't know why I'm writing it out in words. I'm going to multiply row 1 by -3, and I'm going to add rows 1 and 3, or excuse me, row 1 and row 2. And I'm going to replace 3. Excuse me, I'm going to replace row 2. Now, just so I'm not confusing you, I'm going to do this in 2 steps. Because I know sometimes you need to see what's happening. Okay, so I'm going to put in blue here. The blue is this, or the second row is that. And now in the top row, I'm going to multiply by -3. So I end up with -3, 0, 0, -6. And now I'm going to add rows 1 and 2 together. Now, when I do this, I want to restore what row 1 was. Row 1 in that step before was this. Okay, and the third row, I'm not touching the third row at this point. If I add now rows 1 and 2, I get 0, 4, 0, and 12. Now, I am one step closer to getting that second row where I want it to be. I want that 4 to be a 1. So because I want that 4 to be a 1, what I need to do here is I need to divide this row by 4. And I'm going to just replace row 2. So 1, 0, 0, 2. And the bottom row, 1, 1, 1, 9. That's not changing. What's changing is my second row. Now I've got 0, 1, 0, 3, because I'm dividing all of those numbers by 4. Okay, and at this point, I know that y is equal to 3. Now, to finish this process, I just need to make this number a 0 and this number a 0. But I can't do it all at once. I'm going to have to do this in two steps. All right, so let me just capture in the next matrix. I already have the first row. I already have the second row. Now I need to do something to either row 1 or row 2, and do something with row 3. I'm going to start with changing this number right here to a 0. Okay, and here's what I can do. I can take row 1 minus row 3, and I can replace 3. Okay, so if I do that, 1 minus 1 is 0. 0 minus 1 is negative 1. 0 minus 1 is negative 1. 2 minus 9 is negative 7. All right. Couple more steps and we're almost done. I'm going to now make this a 0. Okay, I'm going to make this a 0 by adding row 2 plus row 3, and I'm going to replace row 3. So again, just color coding this as we go, and of course my pen just drew blue. Like I said, I'm having a little bit of technical difficulties with my computer lagging here. These stay the same. And when I add those two together, 0 plus 0 is 0. 1 plus negative 1 is 0. 0 plus negative 1 is negative 1. And 3 plus negative 7 is negative 4. And now we just have one more step. Okay, and that is to divide by negative 1 and replace the third row. So 1, 0, 0, 2, 0, 1, 0, 3, and this last row then becomes 0, 0, 0, 1, positive 4. So x is equal to 2, y is equal to 3, and z is equal to 4. And if you put all of those, all three values into all three of those equations, you will find that they all work. So I hope this was helpful.